wonder why. Yeah. But
Abby, get your notes out. Let's go. They're already wrecked. Can't do anything about it. All right, so lesson 40 today, we're going to talk about logarithms and we're going to talk about inverse functions. Let's go, please. Let's get this stuff copied down. All right, my plan for this hour is to get through these as quickly as possible to give you guys as much time as possible to get your homework done. So that, I mean, chances are you're not going to be able to finish all 25 questions, but hopefully you'll get a really good start on it and you shouldn't have too much left. Yes, Jordan, you can do that. All right, so first of all, for laws of logarithms, when we have log b of m times n here, what we can do with these two, when they are multiplied together, we can split them apart by doing what? Do you remember from the past? Anybody remember? We can split them apart by adding them. All right, so we'll show you that in just a second here. Log b of m plus log b of n, all right? And that's any time that those two are multiplied together, all right? Well, the other thing that we can do here is we can do the reversal of that. If that works from left to right, it's also going to work from right to left, which is the case down here. Now, this only works when we have a log of each one of the terms here, and they're all the same. If they're not the same, you're going to have to do something to make them the same. So what we've got down here is we've got log a of 3 plus log a of 10 equals log a of x plus 6. Well, what that means is on the left side, because the bases are the same here, we could multiply our 3 and our 10 together to get log a of 30, and that equals log a of x plus 6. All right, now from there, because both of these a's are still the same, we can just set 30 equal to x plus 6. All right, and then we can solve that quickly. X equals 24. All right, and if we were to plug in, say that this a were an actual number here, we could plug this in to our calculator. The left side would end up equaling the right side here. All right, so whenever you have, either you have two things multiplied together, you can split them apart by adding them, or if you have two things added together, you can put them together by multiplying. All right, so that is the product rule of logarithms. Okay, if we have a product rule, we also have a quotient rule. All right, so we're gonna do the same thing, or the same concept here. So we've got log b of m over n. Well, what that turns into is we can say that log b of m, instead of adding like we did when it was the product rule, we're going to subtract these. All right, and all that means for this is when we have two things divided together, we can split them apart by subtracting. Okay, so if you look at the one down below, our log 4 of x minus 3 minus log 4 of x plus 7 equals log 4 of 5. Well, the left side, because these 4's are the same, we can combine these two. All right, and how we do that is because it's a subtraction, we can end up dividing these. So we get x minus 3 over x plus 7 equals log 4 of 5. Well, once we get to this point, we can do the same thing we did on the last page. Because these are both log 4s, we can just set x minus 3 over x plus 7 equal to 5. And then we can cross multiply and solve this. All right, so x minus 3 equals 5x plus 35. Subtract an x over. Subtract a 35 over. Looks like x equals negative 9.5. All right, so really quick, do me a favor. Graham, you got your calculator out. Do you know how to put logs into that thing? You go to math, and then it's like down towards the bottom of it. What I want you to do is if we put this negative 9.5 in here for x into this first one, we would get a negative 12.5. Graham, go ahead and type in this into your calculator and tell me what you get. Log 4 of negative 12.5. It doesn't work? Do you type it in right? Yeah, I did 4. Riley, you type it in right? All right. And that is the case. All right. Even though we did all the math right. Now, it's not because x is negative here. Okay. But when we plug it back in, what we get right here is we get a negative number. All right. Now, think about this. If we were to flip this into exponential form, okay, we're trying to find the answer here. This would be 4 to the x equals a negative 12.5. This is already positive. Is there anything that we can put in here for x to make it negative? There isn't one. Okay, so whenever this number here is negative, then our answer is no solution. All right, so got to be careful with these to make sure that that it works for the problem. Okay. All right, questions at all there? All right, next one. Log b of m raised to the n power. All right, now the first one was called product rule. Second one was quotient rule. This one is called power rule. All right, because we've got our logarithm raised to a power there. All right, now this is the one that we use the most often, to be honest. We do use those other two every once in a while, but this one gets used quite a bit. All right, all that we do whenever we have a power here, we can pull it out in front. So this becomes n times log b of m. All right, so whenever you have an exponent, bring it out to the front. All right, or if you have a number out in front, you can always bring it up to the exponent. Okay, and those reverse each other. All right, so we look down here. We need to solve 3 times log b of x equals log b of 8. All right, now we got to figure out what x is here to be able to do that. Well, this 3 we can always put up there into the exponent. So we'd have log b of x cubed equals log b of 8. Since these b's are the same, then we'd have x cubed equals 8. What is x going to equal here? 2. And if we throw that back in, that's positive, so it's going to work there. All right, so x equals 2. Log 12 of x equals 2/3. Log 12 of 64. I would bring that up there first. So log 12 of x equals log 12 of 64 raised to the 2/3 power. All right, now this is something that you can do in your head. All right, first of all, these 12s are the same, so this means x equals 64 to the 2/3. What does this 3 mean, first of all? That is the same as the cubed root. And then the 2, we can either put the 2 here, which I have no clue what 64 squared is, so I'm not going to put it there, or you can put it on the outside. Cubed root of 64 is how much? 4. And then 4 squared is 16. So x equals 16 here. All right, that is something that you can do without the calculator. All right, and we can plug that back in. We're not going to get a negative anywhere, so it does work here. All right, so any questions on logarithmic rules here? All right, you're going to see them quite often in the homework. All right. Go ahead and copy this down. And then I'm going to show you 2 different ways to do this problem. You get to pick which way you do it. I think there's an easier way, but I'm going to show you both ways. Stetson, you've got it all written down already, huh? The important parts. You've never seen this before, so how do you know what's important and what's not? You wrote that down? That's all you wrote down? Have any idea what it's for? Maybe you should write that part down. It's kind of important to be able to tell whether they're inverses of each other or not. All right, so down below, we've got 2 functions there. F of x equals 0.5x minus 2, and g of x equals 2x plus 4. All right, now what this says up here, up above, it says you can figure out if the 2 functions are inverses if we put the g of x function into the f function and what comes out is an x. And then we also have to put the f of x function into g, and it's got to come out as an x. All right, you cannot just do one of them. There are functions out there where you get an x for the first one and you do not for the second one. Okay, so that's what I'm going to show you first. All right, first of all, we've got to find f of g of x. What this means is we're plugging the g function into the f function wherever we see an x. So we would have 0.5, and then this thing goes in there for x. So 0.5 times 2x plus 4 minus 2. All right, we run the 0.5 through, we get x plus 2 minus 2. That would just end up being an x. Okay, that's what we're supposed to get for this to be a function. So the first half is good. Then we've got to do the second half here. All right, so we're going to plug the f function into the g function wherever we see an x. And then we run our 2 through there. So we get x minus 4 plus 4. We get an x for that one also, because we got x for both of these. The answer is yes. Okay? Now, that's one way to do it. That's how the book does it. Okay, there's nothing wrong with it. It seems a little bit longer to me than what it has to be, though. All right. What do we know about how to find an inverse? We talked about this before. It's a two-step problem to find an inverse. What are those 2 steps? Switch what? Switch the x and the y, and then solve for y, right? So say we did that for this first one. Remember, f of x is the same as y. So we've got y equals 0.5x minus 2. Say we switch the x and the y here. And then we end up solving this thing for y. So we'd have to add the 2 over. And then to get rid of the 0.5, we're going to multiply by 2 there. So y equals 2x plus 4. Is that a way to prove that those are inverses of each other? Sure it is. Okay, so if you just want to do this, which we've already talked about in here, that's fine too, as long as this one matches up with your other function. It's totally fine. Okay, you could have done it the other way. You could have said y equals 2x plus 4 and found the inverse of this one, and then as long as that equals this, then they are inverses too. Okay, so 2 different ways to do it. Okay, question? No, you don't. You only have to do it the one time. Okay. Connor asked, you know how we had to do it for both of them here on the left side? We had to do both here. Okay. If you're trying to find the inverse equation, you do not have to do it the second time. All right. If you take the inverse of the first one and it matches the second one, then it's going to match the other way around too. All right. Now, there are problems with that though. And that's what this one looks like here. So go ahead and copy this one down. Now, the way that I'm going to do this one is I'm going to do it the way that I just showed you, which we've already done in here, where we switch the x and the y, and then we solve for y. All right, so, and I think we're going to do it off of this first one. So y equals 1 over x minus 3. All right, if we switch the x and the y here, we get x equals 1 over y minus 3. And then we've got to solve that one for y. What would you do to solve this for y? Yes, correct.
Switch the y minus 3 in the x.
Yes, that's all we'd have to do. Because remember, this x here, I could write that as x over 1. So what happens with this, first of all, you could cross multiply this. Okay, I wouldn't run the x through this thing because you're just going to have to split it apart afterwards. But what Graham said was these two can just switch spots here and it's not going to change anything. So we've got y minus 3 equals 1 over x. And how do you get y by itself now? We add 3, right? Now, we add 3 to both sides. So it looks like y equals 1 over x plus 3. Okay, and then what this one says is y equals 3x plus 1 all over x. Now that makes it look like they're not the same, right? But what do we see in the second one? We see that we have one denominator here. In the first one, technically we have 2 denominators here. So to fully figure out whether these are inverses of each other, we've got to go a little bit further with this one. we've got to get a common denominator here, which means we need to take this 3 times x over x, which then would give us 1 plus 3x over x. Now, those are the same, aren't they? All right, so by switching the x and the y, you have to make sure that you can do all the work you can to try and get it to match the second one before you can say that they are not inverses, okay? So just be aware of that. That pops up every once in a while, all right? But if you want to do it this way, or if you want to do it the other way is going to work, okay? And you would get x, or you'd get the first one to equal x, the second one to equal x, all right? But do remember, though, that you have to, if you're going to do it the other way, you have to do it for both sets, okay? You cannot just do it for one and call it good. All right, any questions on lesson 40? All right, lesson 41 then. All right, so what do we know about sine? Sine is what over what? Opposite over hypotenuse. All right, what do we know about cosine? Adjacent over hypotenuse. And tangent is opposite over adjacent. All right, now those three we've started to use quite a bit this year. All right, so far what we have not used is we have not used these other three this year. I know you guys were introduced to it a little bit last year though. Okay, these are cosecant, secant, and cotangent. Okay, now there is a fraction that works for each one of these too. Okay, first of all, the thing to realize is sine and cosecant work together. They're not equal, they work together. And how they work together is cosecant is the hypotenuse over the opposite side. So they are reciprocal functions of each other. All right. Same thing with cosine and secant. They're reciprocal functions of each other. So this would be hypotenuse over the adjacent side. And then tangent and cotangent also work together. This would be the adjacent side over the opposite side. Okay. Now, I'm gonna be honest. The way that I do it is I just need to know which one of these three functions match up with these three functions, okay? I don't ever remember that these are actually how they work out, okay? And I'm going to show you what I mean by that when we do some of these problems here. All right, so we need to find what secant of 300 plus cotangent of 510 is. All right, Graham, it looks like you're the only one that has a calculator out, so I got to pick on you. All right, no, just leave it out. Graham, find the secant button on that calculator. It's gonna take you a long time because for most calculators that doesn't exist. All right, Abby, you can find yours on there though, can't you? Yeah, yours, I believe, is on there. Okay, now, for those of you without, Gavin, yours isn't on there. Brett, if you grabbed a calculator, yeah, it's not on there. Okay, none of your calculators are smart enough to be able to figure it out. I don't believe. I haven't seen one yet outside of the one that Abby has, where you can do that. So, what are you gonna do here? all right, is we're going to do a lot of the same stuff that we've done in the past. All right, so secant of 300. We're going to draw out the triangle for it. So 300 degrees, what quadrant is that in? Fourth. With a reference angle of how much? 60. So we've got a 30, 60, 90 triangle here, which means 1, square root of 3, and 2. The square root of 3 is negative. All right, so would you guys agree with that triangle up there? Okay, now, what we know is secant works with which one? Cosine. So if we said cosine of 300, cosine would be 1 over 2, right? Because it's the adjacent side over the hypotenuse. So cosine of 300 would be 1 over 2. Secant of 300 would be 2 over 1. All right, so when we find what secant of 300 is, we're eventually going to get to it too. All right, cotangent of 510. Well, first of all, I'd subtract 360 out of there to get us down to 150. 150 ends up being in what quadrant then? In the second one, with a reference angle of 30 degrees. So for that, we've got 1 square root of 3 and 2. Square root of 3 is negative again. The 1 is positive. All right, now cotangent works with tangent. So if the question was tangent of 510, we would say it's 1 over negative square root of 3. Well, cotangent is just the opposite of that, or I should say the reciprocal of that. It'd be negative square root of 3 over 1, or just a negative square root of 3. So our answer would be 2 minus the square root of 3. Okay, now I wrote down all the steps here, okay, so that you guys could see it all. At some point, what you're going to do is you're going to look at this triangle and you're going to say, okay, tangent is 1 over negative square root of 3. Cotangent's the opposite of that. So it'd be negative square root of 3 over 1. And then you're just going to write down a negative square root of 3 after you get used to it. Okay, same thing for secant of 300. Secant works with cosine. Cosine's 1 over 2. That means secant is 2 over 1. Okay, so I understand there's quite a bit of steps written down there, but a lot of those steps, once you get used to it, you're going to start skipping, which is totally fine. All right, any questions there? All right, so let's phrase it up a step here. Okay. All right, copy down the first one. Don't worry about the second one. Not yet. All right, for this first one, what would you do first here? I would get it into degree form too. Remember, that is taking each one of these times 180 over pi. All right, so then this turns into 2/3 cosecant of negative, pi's cancel, 4 goes into 180 45 times negative 3 is negative 135. Minus secant, pi's cancel, 4 goes into 180 45 times. That is 495. All right, so let's work on this first one here. Cosecant of negative 135. Negative 135, it would be in what quadrant? It'd be down here in the third one, because we'd come down and around. Reference angle of 45, which means 1 square root of 2. Both of these would be negative signs. Okay. Now, so we've got our triangle drawn right. What we know for sure is this 2/3 is going to come down, and then we got to figure out what the fraction is here. Cosecant works with sine, so that would be 1 over the square root of 2. Except we want to flip that. So it'd be square root of 2 over 1, or over negative 1, which would just be a negative square root of 2. So then this term turns into negative 2 square root of 2 over 3. All right, questions there at all? Okay, this one I'm going to subtract out 360 to get us down to 135. Now that's positive 135, so we're going to be up here in the second quadrant. 45-degree angle though, so 1, negative 1, square root of 2. Secant works with cosine, so cosine would be negative 1 over the square root of 2, except we've got to flip that, so that would be a negative square root of 2 there. Negative and negative make positive, so we're going to have this first one plus square root of 2. And then we got to get common denominators here, so we're going to multiply this by 3 over 3. So we would have negative 2 square roots 3 plus 3 square roots of 2 all over 3. And then we can add our numerators together here. So we would have square root of 2 over 3. All right, I skipped some steps there. Did I lose anybody? Or do you have any questions? All right, so really what we're doing here, guys, is we're doing all the same stuff. We just introduced some new functions and how to deal with them. Okay, so I want you to go ahead and try the second one. Okay, the steps to the second one exactly the same as what we just did on the first one. Okay, I'll give you a minute or so to get rolling, and then I'll start to do it up there too, so you can check. So if you get through the first one there, I believe secant of 600 should be the same as -2. Okay, I kind of stopped there because I know that we kind of struggle with it when it's thrown on the axes here. All right, so any questions on how to get -2 first of all? All right, so for cosecant then, cosecant works with sine. So sine is opposite over hypotenuse, which would mean that cosecant is hypotenuse over the opposite. Now, when it's on the axes like this, okay, first of all, our hypotenuse is 1. Remember, that's always the distance from 0, or from the origin. All right, so we're putting this on the unit circle then. So the distance here would be 1. Okay, the opposite side is always your change in y. Well, your change in y here from the origin to that point is also a 1. So it's going to be 1 over 1 there. So we're going to take that -2 from the first one and add 1 to it. And you get an answer of -1. Okay. All right, any questions? All right, now, I realize, first of all, technically, we're only adding 1 step. This is not an easy step to remember, okay? So that's why I'm telling you, use kind of your previous knowledge and figure out which one works with which one, and then just flip the fraction, okay? I think that's the easiest way to go. All right. A little bit easier problem here. We've got 2 word problems. Got to throw some permutations in there since we just did that the other day. Question, Max? If you looked at the title, it said that. I don't know. It's a weird thing in this book how they put 2. Sometimes there are 2 things that work really close together, and most of the time they don't. And this would be an example of that. Oh, Maxwell, we're going to do this without a calculator. You don't even need it. All right, how many permutations are there of 22 things taken 6 at a time? All right, now how we get this set up. Now, first of all, it does say permutation here. All right, so there are 2 different ways to do this. When it says permutations, all right, you could set it up as the permutation equation. All right, remember what this is NPR. And all of your calculators have this button on them, okay? It's hidden sometimes, all right? But you'll see this NPR button on there, okay? The N is always the total number of objects that you have in the problem. So in this case, it is the 22. The R is how many you're taking at a time, okay? So that would be the 6 here, all right? Now the equation for this is n factorial over n minus r factorial. Okay, now, based on the numbers, this is something like I've already told you guys, your next test, which is up on the board, will be half calculator, half no calculator. All right, if the numbers are nice enough, this is a problem that could be on the no calculator part. So we definitely still need to know this formula for this, n factorial over n minus r factorial. Okay, so how this works for this problem is we'd have 22 factorial, which you guys can figure out really easily, right? No. And then on the bottom, we'd have 22 minus 6 factorial. So technically, we'd have 22 factorial over 16 factorial. Now, what you could do is on the top. We've talked about this before. You could take 22 times 21 all the way down to 16 factorial. And I stopped at 16 factorial because that's what we have on the bottom. Those would cancel out, so technically, you just have to multiply those together, right? No matter how mean you think I am, I would not put this one on the no calculator test because that is a lot of work to do. So, did we find the NPR button on your calculator? If you've got one of the graphing ones, if you look under math and you go over to, I think it's probability, it's under that. Okay, for some of the smaller calculators, it's on the front page of your screen. So Brett, I would say that's just on the front page, isn't it? Like on your calculator? Did you put your calculator away? Okay, so you listen. The first time you've listened to me ever. All right, Graham, did you find the answer for me? No? Gavin, you got the answer? Isn't it on the front of your calculator there? Stetson, you got it for me? Okay, say it nice and loud so I can hear you this time. 53,721,360. 360. All right. So there's your answer. All right. So out of those 22 things, normally there's what, 24 of you in here? If I would just take 6 of you students at the same time, I could have well over 50 million different ways to match you guys up, for example. Okay. If you can't find that button on your calculator, come back and show me your calculator. I'll help you find it. Okay. Down at the bottom, though, down at the bottom is definitely one I could throw on a no calculator test. Okay. How many different ways can 12 people be lined up 4 at a time? Okay. This is still, whenever you see this, how many different ways? All right. That is talking permutation. So this one would be 12p4, which would mean 12 factorial over 12 minus 4 factorial. So this would be 12 times 11 times 10 times 9 times 8 factorial there. And I stopped at 8 because that's what the bottom is 8 factorial. Those cross off. 12 times 11 is 132. 132 times 10 is 1320. And then you can multiply by 9 pretty quick here. So even though it ends up being a fairly big number there, that is one that you could do. Okay, so there are 11,880 different ways to line up those people 4 at a time. All right, questions at all for me? All right, like I said, I tried to be quick. All right, so you've got about 40 minutes or so to get homework done. All right, your homework. Okay, just like normal when we do 2 lessons. Okay, lesson 40 and 41. 25 questions. Okay, as it says on the board, you guys will have a lesson 40 quiz next week, Wednesday. Okay, and that'll be over any of the 30 questions there. Okay, so you can decide what you want homework-wise. All right, out of those 25. Kenzie, what was that? The test on Thursday is the next week. Give me just a second. Okay. All right, but yeah, give me a second here. All right, you 3 online, that's all I've got for you. So you